Okay, so coordinate bond, as people ask me. First of all, coordinate bond is nothing but a failure of Lewis dot theory. Let me try to explain this by a very simple method. So, this guy Lewis was of the idea that there should not be any octet violation. Octet means surrounding every atom known before and after bonding to have 8 electrons in its ultimate shell. With bonding or without bonding, it should exist like this. Now, VBT gave a very different idea. It's never about the octet, it's about stability. It's about stability. Two orbital regions will overlap to form a bond. It may be sigma, it may be phi, it may be delta. Now, here comes the problem. Let's suppose we take a molecule like SO2. So the VBT consider very simple. SO2, sulfur has 6 valence electrons. Oxygen, there are 2 oxygen atoms with a valency of 2 negative. So they will take 2 electrons, 1 sigma, 1 pi, 1 sigma, 1 pi, and the 2 left are lone pairs. So this is how the VBT presented the molecule of sulfur dioxide. Pardon me, happy lone pair here. So this is the actual structure. Now Lewis was stuck with one situation. Oxygen and sulfur both are group 16. So their valency has to be 2. He was still stuck in the Mendeleev era that the valency cannot exceed the defined valency of the group. Such a maniac, this guy, he ruined chemical bonding for us. So according to Lewis, this was SO2. Now sulfur has 6 valence electrons. Oxygen has 6 valence electrons. Now what happens is oxygen and sulfur will share 2 electrons and complete their octet. So it is sorted. This is SO2. But now the problem arises, what about this oxygen? So Lewis said this lone pair, this is electron pair, there is a space for 2 electrons. So they just overlap in such a manner that there's a shared electron pair between sulfur and oxygen with both the electron belonging to sulfur. That is why people fail to understand coordinate bonds. So according to him, this is how SO3 would look like. Lone pair, bond pair with 2 oxygen, and this electron donation, not exact donation. It's still with sulfur, but it's sharing both the electrons, the oxygen as well, to complete the oxygen's octet. And this is oxygen. So, if someone wants to define what's a coordinate bond, so it is a shared electron pair, usually sigma in nature, in which both the electrons are coming from one of the atoms. So that's Lewis' misconception of coordinate bond. Now, this is not the actual question. The actual question is asked is which of the following has coordinate bonds? So there is a very simple trick. If sigma bonds exceed the group valency, it has a coordinate bond. Let me give you an example. Like I have CO2, NO2, okay, CO2, NO2, SO2, and P2O3, P2O5. Now, this is how it works. The number of bonds over here with carbon and oxygen are 4, and carbon's valency is equal to 4 as well. So it does not have a coordinate bond. Does not have a coordinate bond. NO2. Nitrogen's valency is 3 according to the group. But here, odd electron sharing with 2 with oxygen, and the other electron pair, it goes into oxygen and forms a coordinate. So yes, there's a coordinate bond, right? There's a coordinate bond over here. All right. Why I'm saying it's a coordinate bond? Because it's still incomplete. So how is it sharing another electron with someone else? Correct? That's how it works. SO2, valency 2. Sorry, valency 2. Bonds, 2 sigma 2 pi. 4 bonds, yes, coordinate bond is there. P2O3. Phosphorus, valency 3. Valency 3. Okay. Number of bonds per phosphorus 3. No coordinate bond. No coordinate bond, no coordinate. P2O5, obviously 3 valency 5 bonds. Yes, coordinate bond is there. So just remember, if sigma bonds, ठीक है, if sigma bonds or sigma plus pi bonds, if they exceed the group valency, your molecule is a coordinate bond. You can count the number, you can never find which one is that. Like for example, NH3 has a lone pair. It goes into H positive and forms NH4 positive. Now, NH4 positive, we have hydrogens, and nitrogen exceeds its valency by 1, so formal charge of positive is there. But looking at the structure, can you tell me exactly which H plus is one of these? No, right? You know out of the four, one is a coordinate bond, but you can't actually pick it out because coordinate bond actually doesn't exist in the timetable of VBT. According to VBT, everything is a shared electron pair. One of the shared electron pair can be used as an exceeded valency. So it gives a formal charge of +1, which is again a failure of Lewis dot theory. So coordinate bond basically means an electron pair shared between two atoms in which both the electrons belong to one of them. Its pi version is called back bond. If you see the pi version, COO. Now carbon has a vacant p orbital, oxygen is a lone pair. It can back bond to a pi bond. So this pi coordinate bond is called back bonding. It's a very different thing. Okay, so this is how I can explain coordinate bond at my best. Sharing an electron pair in which both the electron belongs to one of the atom. Thank you.